So our module today is energy availability. We're going to be looking at fossil fuels in general, and the three main ones are petroleum, coal, and natural gas. And where are they? Are we going to have enough for the future? Are these the right questions? And here's the part where I stop because it's a fun little story. When we do the barrel of oil, we abbreviate that BBL. And you think, well, barrel, would that be BL? What's up with that? Well, look at that blue barrel right there in front of you. Well, they figured on 40 gallons for a barrel of oil. But by the time it got there in the old wooden barrels, some of it had leaked and evaporated out. So to make sure the end destination got 40 gallons, they loaded up a barrel that would take 42 gallons. And then they wanted to make sure nobody got them confused. They painted these blue. So BBL is blue barrel. So that's how the barrel of oil got the denotion of BBL or blue barrel. So anyway, fun fact number 212. So on we go. But if we look at international comparisons, where do we stand with the rest of the world? I think you'll be surprised. I think one of our homework assignments, I think in the next module, will really clue us in on this one. But Kingdom of Saudi Arabia, KSA there, was a top 5 producer in 2011. And these change from year in to year out. 2013 will be different than that. But again, you kind of have to look at them in comparison with the top leaders there. Russia is next with 10 million barrels, a little over 10 million barrels a day. Hey, look who's in third spot. United States of America, the one that has to import so much oil. We are actually the third largest producer of oil and oil products in the world. After that is Iran. China is down there at number 5, all in that area. I think Iraq is coming up pretty good. They're going to have increases in productions, but still those will change from year in to year out. The data comes from the CIA World Factbook. That does bad connotations throughout most of the world. Some of the world, who knows, but either way, they keep a log on economic statistics for every country on the planet. It's a great place to search for basic economic data. How about coal? Top 6 producers, the People's Republic of China, 3.47 billion tons. Remember, that's a ton with an E on there. TON with no E is a different ton. Make sure you look that up and get that straight in your head so you don't get that confused. United States of America is about 1 billion tons. India is about 585 million tons, or about half of what we are, 60% of what the United States is. Australia is after India with 414 million tons. Indonesia is down there, and Russia is bringing up the rear. So you look at that spread there, it's almost a 10-to-1 difference from the top producer being China. Just to put it in perspective, 5 years ago when I first taught this course, China produced about 1 billion tons, and now they're over 3.5. So that's an enormous leap in just a short period of time. How about natural gas? Woo! Now wait a minute. Let's go back just for a second. USA was second on that one, third on oil. Natural gas, top producer. 24.7 trillion cubic feet of natural gas a year. Russia's just behind us, 23 million, a little over 23 million. Canada is, wow, we import natural gas from Canada, and yet they're a fraction of what we produce. China is 3.63 trillion cubic feet. The Kingdom of Saudi Arabia, well known for its oil supplies, not so much for natural gas. Recent natural gas production through fracking has put the USA in the #1 spot. And for many years we thought the United States would be in a terminal decline on natural gas production, but this issue of fracking has brought us just barely over into the top 1 category. This data came from the Energy Information Administration, the EIA website, under the category of marketed natural gas. Marketed? What do you mean marketed? Well, there's natural gas with condensates in it that you can condense out and sell as natural gas liquids, and so you got to pull that out, so that doesn't come under the total of natural gas that they sell. There's also natural gas that they get out of the earth and have no place to put it, so they flare it off, burn it off, which is terrible waste. Or they use the natural gas that came out of an oil field to pressurize the well field to get an increased amount of oil out of the well field. And eventually, when the oil runs out from that field, they'll get the natural gas back. So they repressurize an oil field with natural gas. So you got to be careful on the numbers you use for natural gas, because some of it is what comes out of the well isn't what goes to the market. So energy content, all these sources come at us, our energy content, what's in all these things. Oil is about 5.8 million BTUs per barrel of oil. Natural gas is about 1,000 BTUs per cubic feet, and coal is about 20 million BTUs per ton, English ton, which is 2,000 pounds. So if we can take a look at our conversions for all these different energy volumes, energy contents, energy sources, and come up with who's producing what, we find out China is in the top spot in the world for producing the most amount of energy. And they get that way because of their vast production of coal. They are way down the list on oil and natural gas, but when it comes to coal, there's nobody even close. So we used to hold the top spot until just about 3 years ago, about 2010. I think China passed us up with their coal production that vaulted them into the #1 spot. But before that, we were #1. Produced more energy than any other country on the planet, and yet it still wasn't enough. So, where's this energy going to come from in the future? And all this energy production, what effect does that have on the planet? Can we both afford the price in monetary units and also the price in what it does to the planet to extract it from our surroundings? Where do we go from here? So, a researcher a number of years back in 2006 came up with what is known as an export land model. I first taught that in the summer of 2007. I think it was the first time this topic was taught at a university course was when I brought it up. It's a very simple model and basically says that I've got oil production, and in many fields and many countries around the world are in decline. It might be a slow decline, a couple percent a year, but nevertheless a decline. At the same time, with the world oil price being pretty expensive, those countries that make a lot of oil, produce a lot of oil, have a lot of money. And so their internal economies are going really well. So if your internal economy is going well, what is your internal consumption of oil doing? Well, that's that blue line on that graph right there, and that's going up. So if I'm in a permanent but slow decline in my oil production, like many countries are, at the same time my oil consumption is going up, what is happening to my oil exports? Well, they're plummeting like a rock, like a cliff, and that's that red line. So in a matter of 9 years, we go from 7 million barrels a day to 2 million barrels a day exports. Well, that's all well and good for the exporting country that has the oil and they're still running their economy, but what about the countries that import oil? How does that work out for them? In the case of this example here was Russia, and Russia didn't quite fit this bill in the example given in 2008 because they've kept their fields going. They're at a kind of a plateau. They haven't changed their production much at all. Their declines have been matched by new production, but just barely. They haven't changed much at all. So you might say from this, that's a flawed model because it didn't work for Russia. Well, here we have an example for two important countries. That would be Indonesia. We looked at the history earlier in some of these countries and found out that Indonesia was one of the founding members of OPEC. I think they joined in 1960, right after the first meeting of OPEC. And so you have a country that made its name exporting oil, and what do now? Well, they import oil. They had to resign from OPEC, I think in 2011 or 12, because they no longer export oil. So they're in permanent decline. And how about the United Kingdom? They had the North Sea oil that they first started pumping in the late 70s and pumped that for a good 30 years. And those oil fields that they owned in the North Sea went into decline. And right now, the United Kingdom is importing oil. So again, that unfettered expansion into an oil province, as they call it, you produce from that oil array of oil fields, and you produce for a number of years, and you reach a maximum height of production, the most amount you're ever going to get at one time out of the field, and you reach a slow decline. And that slow decline is matched by internal consumption gains in your country, and so your export volumes drop rather quickly. And that's what the export land model is about. And some of the, look at the last bullet there, net export rate of decline, UK was 56%, Indonesia's 29%. Those are actual numbers, those are not hypothetical, those numbers are what actually occurred in those markets. So where does that leave us? So the export land model might have some problems, it's been presented, it's simplistic, it didn't work in Russia, it worked in another couple of countries. It doesn't matter, because you can look at the world export model, our world export market, and it's dropped from 46 million barrels a day in 2005 to 43 million barrels a day in 2010. So the total amount available to the marketplace has dropped. Now, if you take a look at our expanding developing countries of China and India, and carve out enough oil for those countries to exist, I mean, again, that's 1.3, 1.1, 2.5 billion people on the planet. This seems reasonable. Then the amount of oil available for the rest of the world is small and getting smaller. And the big importing nations on the planet or regions would be the United States, China, Europe, South Korea, Japan. So the conclusions from this model for those countries are rather alarming. What about natural gas and coal? I mean, we get a lot of the vast majority of our transportation fuels from oil, but we get a lot of energy from natural gas and coal also. So, headlines: with U.S. awash in natural gas, why aren't fuel bills falling? That was the Washington Post, December 14, 2012. After the boom in natural gas, what happens next? That was a headline in 2012 in the New York Times. So, those are all the headlines in the United States of America. Boom in natural gas. If we have a boom, how come we're still importing natural gas from Canada? Doesn't seem like a boom to me. And what you find out is that you have a lot of oil, natural gas coming out of all over the United States. In fact, 24 trillion cubic feet. We import still about 2 trillion cubic feet of natural gas. So let's look at some of the suggestions on what to do with this supposed blast of natural gas that we're getting in this country. We'll move some of our traffic, our transportation fuels to natural gas, CNG, compressed natural gas. There's been a lot of suggestions on that. Let's just say we move 25% of our total vehicle miles traveled to natural gas. Where would that leave us? Well, we'd use some natural gas for transportation. How about if we take the natural gas we use for electricity, which is now just increasing significantly. Now we get 30% of our natural gas from, 30% of our electricity from natural gas. What about if we got 50%? I mean, that would get our coal numbers down, and that would be good for the atmosphere, but natural gas 50%, some people recommend that. And what if we got rid of imports? What if we produced enough to get rid of all imports? Where would that leave us? Well, you can add up those numbers. Those are fairly straightforward numbers to calculate, and you would need an extra 11.7 trillion cubic feet of natural gas to meet those modest increases. Now, if we're making 24 trillion and 11.7 is almost 12, that means a 50% increase in production of natural gas in the entire country. I don't think anybody is suggesting that is possible with the known reservoirs of natural gas in this country. So even a modest increase in the use of natural gas, and we have numbers that seem to be unsustainable. And how about coal? How long we think about it? How long have we been mining coal in the United States of America and other countries to boot? I mean, think of England. It's been, 400 years most likely in England. In this country, 150, even 200 years on the eastern mines. So the eastern mines are kind of getting played out. So if I'm a power plant in the eastern half of the United States of America, remember we're a pretty sizable country, and I have to ship my coal 1,000 miles from, say, West Virginia, Kentucky, Illinois to Florida for electricity. And that coal has roughly 10 to 12,000 BTUs per pound. And now those mines get played out, or the unit labor costs go up. So I've got to get my coal from farther afield, and I have to go out to the western part of the country. Well, now I just doubled my miles, and the western coal has about 8,000 BTUs per pound, or about a third less BTUs per pound. So my energy content is lower, and my distance doubles. What does that say for the price? And you can see what's happening in our coal market. 52% of our electricity was produced from burning coal just a few short years ago. Now it's about 37%. So you've got the world export market for oil shrinking. Coal is dirty and expensive, or getting more expensive. Again, it is a cheap fuel, but the price trend is going up. Natural gas can't cover all the increased demands that we're looking for it to cover. So those are things that we have to worry about. But what about our environment? What about where we're getting all these fuels from? Okay, and there's a lot of divisive talk about this, and this class isn't about the atmosphere, it's about energy. They are directly related, of course. but we don't spend a lot of time on that. But I would like you to just have a thought process here. Forget the divisive talk, the cherry picking of data, the he said, she said type of arguments relating to this topic, and ask yourself, how many breathable atmospheres have we found in the known universe? Well, as of this recording in 2013, there's only one I can think of that's on this planet, Earth. So also ask yourself, have we increased the CO2 in our atmosphere? Can we just measure the CO2 content in our atmosphere and have for the last 130, 150 years? Yes, we have, and we have increased it literally every year. So can we show how this changes the way the sun's energy is absorbed in the atmosphere? Yeah, that's radiation heat transfer, and that was my background in college, and actually what I did when I worked in aerospace. So yeah, it's a pretty simple experiment to show that the sun's energy is absorbed differently in the atmosphere if you change the atmosphere, especially with gases that absorb sunlight differently than the gases that are currently in the atmosphere. So we can say that it changes the way the sunlight's absorbed. So we might not know all the answers, but we have all the facts in front of us. So the last final thing is, what right do we have to treat the only known atmosphere that we have as a giant experimental toilet? Not much.